Hey everyone, Mike here. After years of being addicted to podcasts and YouTube, it's time I made my own videos, so welcome to the first video on my new channel. Apparently the Aussie BIM guru is taking a bit of a break, so I'm going to be your Aussie computational design guru. Actually, I better come up with a more original name and theme tune. Gavin's going to kill me. From the top.
Sorry, I can't count.
I mean, anyone can become a guru. All you gotta do is grow a long beard, cover your face in paint, and sit by the Ganges meditating like this bloke. Or alternatively, start a podcast, and then galaxy brain your way into unqualified opinion to get yourself onto decoding the gurus. It's like this bloke I met a couple of years ago. Just kidding. I love you, Sam. No, my ambition is much bigger than just being a guru. I'm going to give the AEC industry the gift of technological progress, even if that means gods, by which I mean large corporate bureaucracies who don't understand innovation, will peck my eyes out and chain me to a rock for eternity. I'm going to be the Parametric Promethean! Blocks in Rhino. I reckon this is one of the most overlooked and underrated things you can do with Rhino. Actually, you know what? Over the years I've been surprised by the number of colleagues that I've met who claim to be Rhino users, or even Grasshopper users, and they just don't know how to use blocks. And they also don't know how to use sublayers, and they can't understand why I would want to model it this way. I've even had some managers, who will remain nameless, who strongly discouraged me from structuring my Rhino models with blocks and sublayers, and wouldn't resource the development of code to manage this. I think this resistance comes from them not coming from a computational design or software development or BIM background, so they're not really thinking in an object-oriented way. As for layers and sublayers, a lot of Grasshopper users don't really use that properly because when you send the geometry from Rhino to Grasshopper, you're dealing with the geometry objects on their own, so you're not really getting all the metadata like the layer, the color, the user string that comes with the Rhino object. Whereas when you're coding, you can process the Rhino object itself, so these things always stay attached together. When we set up the block, we can put different geometry objects on different layers. That way the code can go through and go, is this a brep or a curve? Is this on layer 1 or layer 2? And from there, you can set up your if statements to make decisions about what to do with that geometry. So that's another reason why it's not a very fashionable approach among the more junior computational designers who don't know how to code. So I'm not going to judge them too harshly for this if they're beginners. Out of the box, Grasshopper just doesn't offer great block support. But there are off-the-shelf tools at Food for Rhino like Elephant or LegoPod, which you can download for free, which do have some block functionality. However, that's still a bit ideologically noticed for my liking. There's also Visual Arc. Now this one isn't free, they have a 90-day trial, but after that you have to rent a license. It also works in a soft BIM way, so it's similar in its aims to what I'm trying to do in some respects since it also uses blocks. It also has its own drawing production built in. They do have some Revit interoperability, but apparently it's quite buggy. Look, ultimately I wasn't convinced that it would give me the freedom and flexibility I need long term, especially if I want to create elements which don't fit the standard categories, or to structure the blocks in a particular way for analytic purposes, or I want to be able to mass produce my elements from code. So I figured it would be worth learning how to manage the blocks myself to get exactly what I need. Once you invest enough time in learning how to manage this in C#, it opens up a lot of doors. I've proven this approach can work many times before. For instance, at Automation, we had a government client who was doing some urban planning. So what we had was each site as a separate block. We could then operate on it at an individual level and apply some rules to one block and some different rules to the one next to it. And at Populous, I started to develop some block-based workflows for going between Revit and Rhino in terms of floors and grids, and also bring that into the bowl tool for the seats. So I'm not really supposed to show you that work in detail for confidentiality reasons. But what I can show you is some other custom components I built separately which work in a similar way. So this isn't going to be a tutorial video where I show you under the hood how my code works step by step. I think it'd be way too long if we did that. It's more just an overview of a few of the nodes I built lately and to try and stimulate some discussion, get some ideas going, see if I can find people to collaborate with. It's also not going to be a beginner's guide to how to use blocks in Rhino. Somebody else has probably already done that and you can just look it up. It's also not going to be how to code blocks in Rhino, although we might do that some other time if people are interested. The best thing about blocks is it lets you take a soft BIM approach. This means that you can maintain the freeform environment you have with Rhino, and then just convert it over to Revit when it's time to make drawings. It also means that by tying the Revit element and the Rhino block together, you can have a bidirectional workflow where you can go back and forth. Hey, this is a great point to do a big shout out to the people at RhinoInside for doing all the work to build the backend and the interface so that I don't have to. I can just piggyback off your work, and I mean, by making it open source, that was the whole point, right? I really believe in RhinoInside. I think it's a game changer, and I'm surprised it didn't kill Dynamo already. All these companies that think they're saving money by not buying the Rhino licenses, they're actually just going to lose money because they're going to put all these resources into doing it inefficiently with Dynamo or Revit API buttons. And the development time is just going to take a lot longer, and you're not going to be able to use everything Grasshopper has to offer. I could keep going on about this for hours, but I'm not going to, so rant over. So here's a simple example of what I'm talking about, how we can take a soft BIM approach with blocks. For now, we're just going to deal with rooms and walls, and we're not going to worry about any other elements. I have here black lines, which are just on a default layer. I have some colored rectangles, which are going to represent the room boundaries. And this is what I mean by sublayers, so spatial planning, apartment, bedroom. So each one of these closed curves represents a room, and depending on which layer it's on, that's a different type of room. So each type of room has its own layer. I plan on eventually building algorithms to generate this, but for now I've manually drawn them. We come to the first of my custom Grasshopper components in this series, the Create Walls component. First thing we're going to do is just switch these off to make it easier to see what we're doing. The first of these custom components takes in lines and converts them to wall blocks. So all we have is a group of lines that I've set, and I've split them into these are the exterior ones, and these are the interior ones. That way later on, when we convert it over to Revit, then all of that data will carry through. The other thing we need is test points. So let's just set those. Alright, so happening here inside the node, it's generating these standard layers. If these already existed in the file, then it'll just skip over that part. But because it's the first time, it takes a while to run to go through them all just because I have a lot of them. Okay. So the test points are specified. Now we're going to get this, and it's not set to run. Okay, cool. Now we can visualize just the exterior ones. So we can change the height if we want. Maybe we can just set that to 4,000. And if we set that one to run, the interior, seam interior are going to be lower because you can have a ceiling and whatever. Okay. All right. Now we're going to set this to true. And voila, we have our wall blocks. Now notice how these don't really join properly. That's okay. They're going off the center line, and the center lines are connecting here, so that's exactly what you'd expect. I haven't built anything for them to join, and I've done that deliberately because I know that Revit already solves that for us, and we're going to be converting them over to Revit shortly. Let's take a look at what these wall blocks actually are. So if we select one, we know because we put it on exterior that it's gone to external walls. And if we go here, it's gone on to internal walls. When we're generating the walls, there's a part of the algorithm which generates a unique number, which helps us track whether it already exists in the document or not. Okay, so if we crack one of these open, let's have a look what we got. So we've got center line from generating curves. So we have a look at the sublayer distribution, turn off spatial planning, building elements, here we go. So external walls, generating curves. Then on the solid layer, we have a BREP, and there's an internal surface which is on the opaque layer. So this is how we're going to separate out opaque from translucent elements. This will be useful later when we're going to do the analytics. For this next graph, we're going to be using another custom component I built, which converts Rhino blocks over to Revit elements. So this is one that needs to run in RhinoInside Revit. Okay, so what we have here is the wall blocks. We can input those with the Lego pod component. Setting bake to true is what is going to actually add these into the Revit. And setting delete to true is what we're going to do the first time, because we actually want to get rid of these from the Rhino document the first time we do it. So when we bring them back later with the other node, then we'll get rid of these ones with the bad wall joins. Okay, so I'm going to go ahead and set that to true. They're deleted. It's referencing a null. And if we come over to Revit, should be able to zoom out and find it. It's over here. Here we go. So there we have our Revit walls with nice joins. Revit's automatically resolved that for us. In the next graph, I have yet another custom component which goes back the other way. So it's going to convert Revit elements over to Rhino blocks. We're going to grab these and we're going to use the RhinoInside standard node which selects graphical elements. Because I've got run set to false and bake, it's not going to do anything yet, but because this is here, it's taking those in and it's sort of visualizing them as solids, but they're not wall blocks yet. Preview's off. Okay, if I hit run, it's going to simulate what these blocks would look like, and we're going to check whether we're happy with them. So I've built a small floor in just so I can change it. So I'm going to just move this 50 mils that way, and automatically, yep, that should move. Alright, just recompute. There we go. And now if we hit run, hey, we have wall blocks. Now you can see the joins are fixed. Our interior faces should be preserved, and better yet, if you go to these, if I go to the user strings, I have the Revit ID. So these guys will be linked permanently because whenever we convert over from Revit to Rhino, it'll know, oh, this is the one I've got to update. And if I go back the other way, it'll go, that's the one I've got to update. So just to prove that, I'll go, let's just move that out like that at a funny angle. Hey, automatically, it's moved it. Of course, we don't actually want that. So we can just Control Z, reload Grasshopper, and recompute, and it's fixed it back to normal. Likewise, if we wanted to update the Revit model based on the Rhino model, we would load this one up again. We would set delete to false because we don't want to lose it from the Rhino document. And we would make a change inside this block. So actually, what's happening with the poly surface and the surface doesn't really matter. What we actually just want is the center line. So if we just move that out by like 3 meters, and we close block, and we set that one. Yep, that is now 3 meters longer, regardless of what this is doing. So we didn't even have to actually update the geometry inside the Rhino model because we can even just go back the other way. And now in the Rhino model, it's got the solid matching up to that line. That was just a demo. Again, we don't actually want either of those things, so let's just undo. This custom component is for creating rooms. For this next part, we don't have to be in RhinoInside Revit anymore. It'll work in normal Rhino. We'll leave it here for now. we turn spatial planning back on and apartment back on, we've got our coloured room blocks left. Now notice how this balcony one is composed of two separate rectangles. That's fine. Okay, so I've got these pre-selected. These are just those closed curves we saw from the different layers, different colours representing different room types. Again, if we just set run to true, then we will get the rooms previewed. Now what's actually happening here, we can set the room height, so just arbitrary 3000. Another thing that's happening behind the scenes is that this is searching the document for walls. This is important because the walls help us to define the interior boundary of the room. If we just set run to true, then we're going to preview these rooms. Once we set bake, it will actually start committing these to the document. Let's take a look at what these room blocks actually are. Minimize Grasshopper, switch over to spatial planning, turn off building elements. Cool, now we can take a look. So what we have here is the outer surface is connecting exactly off those input lines we had in the first place. And this is so we can later use topologic to do topological analysis to find out which rooms are next to each other. But if we wanted to do area or volume calculations, that's not going to be accurate because you would have to subtract the volume or area which is offset from the center line of the walls so that you actually get the interior boundary. That's why we have that separate. They're all on the bedroom layer, but the BREP is for the topology and the curve is for the perimeter. Now we come to the part involving Speckle. Again, big shout out to Matteo and the team at Speckle for everything they've done to build the interface and all of the Grasshopper nodes that they do have. There's a lot of potential to use this, and at my last job at Populous, I was just starting to build some custom Speckle stuff when the redundancy came. No connection, I promise. Anyway, moving on. So what happens if we wanted to start using our room blocks and storing them on Speckle? Okay, let's try with Rhino's default Speckle app. So I have a blank project with nothing in it here, which I've called Room Analysis. Okay, I don't want to select everything, I just want to select my selection, so I'm going to grab these things, selection, drop down everything, selection, set current selection, saying the word selection over and over again, and send it. Data sent to Room Analysis. Okay, so no errors, says it's all done what it's supposed to do. Come up here, go to main latest version. Oh no, where'd all my colors go? Got something for my user strings here, but all I've got for random material is a default display style. There's nothing to tell me what layer these are on or what the hierarchy of the layers is or anything like that, and there's no color. So I couldn't find any settings to change. I know, Matteo, if you're watching and I've overlooked something, I'd love to hear it. All right, so next thing I tried to do was to build it with the off-the-shelf Speckle nodes in Grasshopper. So again, Room Analysis, linking to my stream. I've got my blocks, set multiple Rhino blocks, the same ones. I hit send. Okay, no error message. Did anything happen? Let's have a look. Nope, I guess it just didn't know how to interpret that data. Now for all of you off-the-shelf ideologues out there, I promise you I did spend at least a couple of hours mucking around with the out-of-the-box Speckle nodes trying to see if I could do this without having to build a custom node. This is about as far as I ended up taking it. So what I have here is some Lego pod ones. You can do the instance decompose and the block explode. You can get the data out of there. And then you have to put it into a tree, and then you have to use this objects kit to build it up. First to create the block definition as a Speckle definition, and then to make the block instance as a Speckle block instance. It gets you about as far as the inbuilt Rhino app gets you. But then again, I don't get all that information about the colors and the layers. And I also don't get the information about the sub-objects that are within the blocks. This is one of those classic situations where, because I want to deal with nested data, if you're trying to use Grasshopper nodes alone, you only have a very flat structure on the surface. So in order to actually be able to process that in an intelligent way, you need to be able to code it. So I surrendered and then I just went and built a custom component like I usually do. And here it is. Let's give it a test run and then I'll talk about it. So again, all I have to do, select my blocks. Basically all it does is just converts the Rhino blocks into Speckle blocks. Send it off. Go to the browser. Hey, the colors are there. Let's have a look. Okay, so we actually have the user strings that are attached, which we had like things like the room being a category of a room and being an internal corridor. And each one of those geometry objects inside there also has its data nested with what layer it's on. Okay, so firstly, what we have here is we have layer, straightforward, just a human readable name, but layer full gives you the full path as Rhino going from the outermost layer to the innermost. Color, again, just the color of that layer. And then we have layer colorful, which again is a list of the colors going from the outermost to the innermost. So now that we do have our colored objects with all that data in the browser, can we go back the other way? Let's try just with the Rhino Speckle app. And I have a completely blank document with no layers. Alright, so let's room analysis, receive, it's a colored one. Let's press the receive button, receive completed. What the fuck? Okay, so the way I had displayed that data with the Rhino Speckle app doesn't work. I guess this is something to do with the nesting, the way I've structured the data. This is probably something I should talk to Matteo and the guys at Speckle about. What if I were to instead try one of the other options? Latest, no, let's get the out of the box one. Let's just undo to keep the experiment pure. Okay, what about this one? This time with the out of the box, it's come through, it has constructed the layers, yet they don't have their colors. So if I go in here, this object is just on the default layer now. Before I show you the custom node I built for receiving the Speckle blocks, I think I found a bug in the Grasshopper component. So if we go to our stream, you can see here I've got a few different versions. The most recent one is this upload out of the box one, but we actually want this colorful one here. So if we get the URL from that and plug it in here and paste it, the ID it's coming up with is actually the upload out of the box one. And this is causing my node to fail because the data is structured differently. If I then go and delete this upload out of the box one, then the colorful one is the most recent one, and now it works. Strange, huh? So if any of the people at Speckle are watching, consider that the reporting of a bug. Please get it fixed. So we can unfreeze my node, and then I'll show you how it works. Hey, we created all of our blocks with all the right colors, and the sub-objects within the blocks have the right colors. You may have noticed we have two Boolean options here. We have replace block definitions and replace block locations. Let's start with replace block locations. If I were to run this again for the second time with this set to false, recompute, minimize, we now have two blocks in the same place. This is deliberate. The point of this is that if you had a model which had multiple instances of those blocks in various places, and you simply wanted to bring in the ones from that Speckle commit and keep all your other ones, then you would set that to false so that the locations wouldn't be updated, and you would just be bringing in the ones from the commit, and you wouldn't destroy the ones that are already in the Rhino document. Okay, we just undo that. So we just have one, back to Grasshopper. Let's run that again with true. Now there's just one. If we were to move these, let's say that this is how it is in the Rhino document. We want to get the speckle locations. Then we would run it again. And now they are exactly where they are in the speckle. Alright, now to explain definition. Again, setting both to true does nothing in this case. Let's say in the Rhino document we had changed something about the block, so let's just say this was a little bit bigger, and we were then to run it again. Then it would replace the Rhino block definition with the speckle version of that definition. And that's it. We've come to the end of the first episode. Thanks for sticking around to the end. I am now officially one of those people that goes on the internet to talk about things. You know, for the first episode we just talked about computational design because that's what I do as a job, but maybe next time we could do geopolitics or conspiracy theories. I hope you all learned something. I got to learn a lot about video editing, including how to make the background black. Well, it makes the edges go all funny, but it's better than having a bunch of random strangers on the internet peering into my home. That would be weird. You know what I really need? I need a way to monetize this. I mean, I'm doing all this work for free and nobody's using it. That's crazy. So, I'm open to ideas. What should we do? Should we collaborate together and make this into a software product that lots of companies can use? Or does somebody want to get me in-house to build a very bespoke set of tools just for their company, like Populous are trying to do? Who knows? If you have any feedback for me, you can leave it in the comments or send me a message privately. Otherwise, I'll see you next time in the next episode of Parametric Promethean.